The Economy of Machinery and Manufactures by Charles Babbage 1832. Chapter 8. Registering Operations. 65. One great advantage which we may derive from machinery is from the check which it affords against the inattention, the idleness, or the dishonesty of human agents. Few occupations are more wearisome than counting the series of repetitions of the same fact. The number of paces we walk affords a tolerably good measure of distance passed over, but the value of this is much enhanced by possessing an instrument, the pedometer, which will count for us the number of steps we have made. A piece of mechanism of this kind is sometimes applied to count the number of turns made by the wheel of a carriage, and thus to indicate the distance traveled. An instrument, similar in its object, but differing in its construction, has been used for counting the number of strokes made by a steam engine, and the number of coins struck in a press. One of the simplest instruments for counting any series of operations was contrived by Mr. Donkin. 1*66. Another instrument for registering is used in some establishments for calendaring and embossing. Many 100,000 yards of calicoes and stuffs undergo these operations weekly, and as the price paid for the process is small, the value of the time spent in measuring them would bear a considerable proportion to the profit. The machine has, therefore, been contrived for measuring and registering the length of the goods as they pass rapidly through the hands of the operator, by which all chance of erroneous counting is avoided. 67. Perhaps the most useful contrivance of this kind is one for ascertaining the vigilance of the watchman. It is a piece of mechanism connected with a clock placed in an apartment to which the watchman has not access, but he is ordered to pull a string situated in a certain part of his round once in every hour. The instrument, aptly called a telltale, informs the owner whether the man has missed any, and what hours during the night. 68. It is often of great importance, both for regulations of excise as well as for the interest of the proprietor, to know the quantity of spirits or of other liquors which have been drawn off by those persons who are allowed to have access to the vessels during the absence of the inspectors or principals. This may be accomplished by a peculiar kind of stopcock, which will, at each opening, discharge only a certain measure of fluid. The number of times the cock has been turned being registered by a counting apparatus accessible only to the master. 69. The time and labor consumed in gauging the contents of casks partly filled, has led to an improvement which, by the simplest means, obviates a considerable inconvenience, and enables any person to read off, on a scale, the number of gallons contained in any vessel, as readily as he does the degree of heat indicated by his thermometer. A small stopcock connects the bottom of the cask with a glass tube of narrow bore fixed to a scale on the side of the cask, and rising a little above its top. The plug of the cock may be turned into three positions. In the first, it cuts off all communication with the cask. In the second, it opens the communication between the cask and the glass tube, and, in the third, it cuts off the connection between the cask and the tube, and opens the communication between the tube and any vessel held beneath the cock to receive its contents. The scale of the tube is graduated by pouring into the cask successive quantities of water, while the communication between the cask and the tube is open. Lines are then drawn on the scale opposite the places in the tube to which the water rises at each addition, and the scale being thus formed by actual measurement the contents of each cask are known by inspection, and the tedious process of gauging is altogether dispensed with. Other advantages accrue from this simple contrivance, in the great economy of time which it introduces in making mixtures of different spirits, in taking stock, and in receiving spirit from the distiller. 70. The gas meter, by which the quantity of gas used by each consumer is ascertained, is another instrument of this kind. They are of various forms, but all of them intended to register the number of cubic feet of gas which has been delivered. It is very desirable that these meters should be obtainable at a moderate price, and that every consumer should employ them, because, by making each purchaser pay only for what he consumes, and by preventing that extravagant waste of gas which we frequently observe, the manufacturer of gas will be enabled to make an equal profit at a diminished price to the consumer. 71. The sale of water by the different companies in London might also, with advantage, be regulated by a meter. If such a system were adopted, much water which is now allowed to run to waste would be saved, and an unjust inequality between the rates charged on different houses by the same company be avoided. 72. Another most important object to which a meter might be applied would be to register the quantity of water passing into the boilers of steam engines. Without this, our knowledge of the quantity evaporated by different boilers, and with fireplaces of different constructions, as well as our estimation of the duty of steam engines, must evidently be imperfect. 73. Another purpose to which machinery for registering operations is applied with much advantage is the determination of the average effect of natural or artificial agents. The mean height of the barometer, for example, is ascertained by noting its height at a certain number of intervals during the 24 hours. The more these intervals are contracted, the more correctly will the mean be ascertained, but the true mean ought to be influenced by each momentary change which has occurred. Clocks have been proposed and made with this object, by which a sheet of paper is moved, slowly and uniformly, before a pencil fixed to a float upon the surface of the mercury in the cup of the barometer. Sir David Brewster proposed, several years ago, to suspend the barometer, and swing it as a pendulum. The variations in the atmosphere would thus alter the center of oscillation, and the comparison of such an instrument with a good clock would enable us to ascertain the mean altitude of the barometer during any interval of the observer's absence. 3 An instrument for measuring and registering the quantity of rain was invented by Mr. John Taylor, and described by him in the Philosophical Magazine. It consists of an apparatus in which a vessel that receives the rain falling into the reservoir tilts over as soon as it is full, and then presents another similar vessel to be filled, which in like manner, when full, tilts the former one back again. The number of times these vessels are emptied is registered by a train of wheels, and thus, without the presence of the observer, the quantity of rain falling during a whole year may be measured and recorded. Instruments might also be contrived to determine the average force of traction of horses, of the wind, of a stream, or of any irregular and fluctuating effort of animal or other natural force. 74. Clocks and watches may be considered as instruments for registering the number of vibrations performed by a pendulum or a balance. The mechanism by which these numbers are counted is technically called escapement. It is not easy to describe, but the various contrivances which have been adopted for this purpose are amongst the most interesting and most ingenious to which mechanical science has given birth. Working models, on an enlarged scale, are almost necessary to make their action understood by the unlearned reader, and, unfortunately, these are not often to be met with. A very fine collection of such models exists amongst the collection of instruments at the University of Prague. Instruments of this kind have been made to extend their action over considerable periods of time, and to register not merely the hour of the day, but the days of the week, of the month, of the year, and also to indicate the occurrence of several astronomical phenomena. Repeating clocks and watches may be considered as instruments for registering time, which communicate their information only when the owner requires it, by pulling a string, or by some similar application. An apparatus has recently been applied to watches, by which the hand which indicates seconds leaves a small dot of ink on the dial plate whenever a certain stop or detent is pushed in. Thus, whilst the eye is attentively fixed on the phenomenon to be observed, the finger registers on the face of the watch dial the commencement and the end of its appearance. 75. Several instruments have been contrived for awakening the attention of the observer at times previously fixed upon. The various kinds of alarms connected with clocks and watches are of this kind. In some instances it is desirable to be able to set them so as to give notice at many successive and distant points of time, such as those of the arrival of given stars on the meridian. A clock of this kind is used at the Royal Observatory at Greenwich. 76. An earthquake is a phenomenon of such frequent occurrence, and so interesting, both from its fearful devastations as well as from its connection with geological theories, that it becomes important to possess an instrument which shall, if possible, indicate the direction of the shock, as well as its intensity. An observation made a few years since at Odessa, after an earthquake which happened during the night, suggests a simple instrument by which the direction of the shock may be determined. A glass vase, partly filled with water, stood on the table of the room in the house at Odessa, and, from the coldness of the glass, the inner part of the vessel above the water was coated with dew. Several very perceptible shocks of an earthquake happened between 3 and 4 o'clock in the morning, and when the observer got up, he remarked that the dew was brushed off at two opposite sides of the glass by a wave which the earthquake had caused in the water. The line joining the two highest points of this wave was of course, that in which the shock traveled. This circumstance, which was accidentally noticed by an engineer at Odessa for *, suggests the plan of keeping, in countries subject to earthquakes, glass vessels partly filled with treacle, or some unctuous fluid, so that when any lateral motion is communicated to them from the earth, the adhesion of the liquid to the glass shall enable the observer, after some interval of time, to determine the direction of the shock. In order to obtain some measure of the vertical oscillation of the earth, the weight might be attached to a spiral spring, or a pendulum might be sustained in a horizontal position, and a sliding index be moved by either of them, so that the extreme deviations should be indicated by it. This, however, would not give even the comparative measure accurately, because a difference in the velocity of the rising or falling of the earth's surface would affect the instrument. Notes 1. Transactions of the Society of Arts, 1819, page 116. 2. The contrivance is due to Mr. Hetty, of High Holborn, in whose establishment it is in constant use. 3. About 7 or 8 years since, without being aware of Sir David Brewster's proposal, I adapted the barometer, as a pendulum, to the works of a common 8-day clock. It remained in my library for several months, but I have mislaid the observations which were made. 4. Memoires de l'Académie des Sciences de Petersburg, 6 Tom. I page 4.